Okay, welcome. I'll get started. Welcome to the Bachelor of Science at UNSW Canberra talk. I'm Professor John David Dewsbury, Head of School. I'm actually a human geographer. And what that signals, I think, is, especially in this faculty, that uniqueness of interdisciplinarity, where we can mix science with art, philosophy, engineering, cyber, business, etc. It's a small campus with quite exceptional staff-student ratio, so that interface is really important. I'm going to talk to you for probably about 20 minutes, just giving you an overview of the degree, and then we'll move to the kind of the main highlight. Actually, is for your chance to ask questions, and also not just of me, but of the students here. So looking forward to that. Let me start with the acknowledgement of country. UNSW Canberra acknowledges the Ngunnawal people as the traditional custodians of the lands on which the campus is located. For tens of thousands of years, Aboriginal and Torres Strait Islander people managed the land sustainably using practices adapted to its unique climate, geography and ecology. We honour their unique relationship with the land and their rich contribution to society. I also want to acknowledge the traditional custodians of the various lands on which people who are watching this online are attending the meeting from today. The Ngunnawal people stands for we the people, or us. And I think this recognition acknowledges the cultural, social, economic connection to these lands and waters. Their culture is very deeply entwined with the land, with a profound understanding of the local environment. And I think that we, the people, us, is also what we're here to do today. And I'm very honoured to work here at UNSW, but also with the Australian Defence Force. And you, the public, universities are a public good. They're autonomous, just about, and they do provide research at the cutting edge with the public good in mind. And so working here and in Australia and on lands of the Ngunnawal people is a privilege and an advantage. The talk we're going to do then is I'm going to run through a little bit about UNSW Canberra and this particular campus, Canberra. Then we'll go through some of the school, about the school, the vision, what we try and inculcate in our students here. I'll run through the offerings, so this helps to hopefully prime some of the questions that you'll have at the end. We'll go quickly over some of the entry requirements, and then we'll open up to the Q&A. So about UNSW Canberra. UNSW Canberra, as I said already, is a university working at the cutting edge and intersection with the military academy. And we've been doing this for several years, over half a century. Graduates, and this is something we're very proud of, are very strong alumni in Australia, in the Australian society. And they are leading not only in the local national communities, but international communities, not just in defence, but also in government and industry. UNSW Canberra is the only national academic institution with an integrated defence force. We do have UNSW graduates, almost twice as many postgraduates compared to undergraduate students, so you become part of that environment too, and that kind of reflects our growth and strength as an excellent full-service university campus. Overall, I think this is the other advantage. We are small here and you have that great student-staff ratio, but we're working with UNSW. UNSW is recently ranked again in the top 20 universities in the world. One of the key things for me as head of school is to make sure that we have research-led teaching that can be at the cutting edge. So you're part of a broader community too, 66,000 students at least. Many campuses across New South Wales, and as I said already, we do work at with the great staff-student ratio. Interestingly too, we can work with industry and defence and universities to provide cutting-edge facilities. In particular in science, we've recently had new labs, only about 2 years old, in chemistry, and we're currently refurbishing some of the physics labs. And again, because it's research-led, students get access to these. So about the School of Science. Science, even for someone like me who's more of a philosopher, science is the foundation of most human knowledge. All the machinery, technology in our society comes from this, from the chemistry in biomedicine to the maths in big data analysis. for the geography of extreme climate to the physics of our galaxy. So many changes, even in the last 5 years, in those spaces alone. Underpinning that, science is fundamental. It's fundamental there, particularly for defence, for technology creation. The cutting edges sometimes can be marginal, but the gains can be huge. Computers, computer analysis, data analysis, crunching through the numbers, speeding up the amount of data, how that data can help you in different platforms, aircraft, ships, weapons, explosives to be effective, code making and code breaking to be in charge of that warfare in terms of the information sphere. Science is the bedrock of all that. If you don't have science, you're not equipped. A Bachelor of Science degree from UNSW Canberra offers you, and the students here coming, a diverse understanding of the physical universe. Again, from chemistry into the subatomic, up to the large-scale behaviour of oceans and planets, from computational techniques and data analysis in the very micro-nano data, to new understandings of the human, full stop, and how that actually changes what human behaviour is in our ever-increasing social technical age. The school vision is important in interfacing and bringing all those different complexities and synergies together. To be recognised internationally as a cutting-edge research science school is our aim. Delivering interdisciplinary solutions because we're unique in that proximity and closeness across not only within the school. There's very few schools of science where you have physics, aviation, oceanography, geography, chemistry, etc. in one school, so that you've got colleagues just next door to you, not across campuses. But also then to actually work with nationally specific, but also in relationship to globally connected 21st century problems. We can't do these things alone. We are a meeting place, Canberra. To deliver then also research-led quality teaching to students across our diverse portfolio of assessments, giving them transferable skills in application and innovation. You're here for 3 years. I mean, today you're here for how many ever hours. Maximise those moments. For those here today, talk to people, even if you're going to the golf stand, talk to the TOs there. Engage, converse. 3 years, widening that from a few hours to 3 years. You're here to develop yourselves, and we're here to encourage you. And there's multiple ways and multiple activities that you can do, and that's on show today, not just the science, not just the academics, but also the many kind of societies that are here. This is all fundamental to who you are and who you become and who you can be, and we want to see that maximised, hence why the portfolio of assessments is important. We want diverse ways of understanding knowledge, creating knowledge, but also we've got to be able to translate it. We've got to also make it have an impact. We also want to talk to the public. So these conversations and even these open days are fundamental to that aim. Finally the school strives to be a global leader in science for equity, diversity and inclusion, fostering skills, and science skills in particular, for all. We need to give opportunities for all, because that person sitting here today could be the key to the future. And we need to make sure that everybody is brought up to speed. There might be questions about attainment levels in science and maths and physics in particular. We do a lot of work when you get here to get you over the line, to help you understand, to get over those fundamentals and those difficulties, because you never know. Your particular mindset, your particular experience, your particular background, your particular gender, your particular ethnicity, your particular nationality has a unique set of skills, and we want to maximise that. So our offerings, the major minors, I shall run through this quite quickly. There is a stand in the Adams Auditorium. I think some of you have already been there. Please go over and chat to staff manning those. But I'll run through these quickly just so you can get a feel for what we offer, what kinds of major minors programs you can do. First discipline, it's alphabetical, no priority, aviation. And here topics include aviation technology, fundamentals of flight, aircraft systems, aviation safety, huge. We're developing that more broadly outside the undergraduate area. Airport operations and systems, air traffic management. It's very good advantage, again, of being in Canberra, national capital of all these agencies, but also a good airport. We have very strong links with Canberra Airport. Again, we work very closely with Aviation School in Sydney. So again, you get those kind of dual capabilities and capacities. So a lot going on in the aviation space, and we've just in the process of completing a new teaching research lab, which simulates with 8 screens, completely 360 surround, a kind of an aircraft management, traffic management tower, but it can also be done for flight simulations. Chemistry. Organic chemistry, inorganic chemistry, biological chemistry, supramolecular chemistry, explosives. A lot of the fundamentals there in chemistry. We don't do biology here, but where you might lean into that a little bit is in the organic chemistry realm. Computer science. Topics here include computational problem solving, introduction to programming, computer technology, data structure, representation, securing networks, and computer language and algorithms. This is in another school, but you do become part of science, and you can do this as a science major, as a Bachelor of Science, and in particular around the maths. Geography. Coastal geography, cultural geography, social geography, environmental hazards, and geographical research methods. One of the things about geography, we don't do labs so much, but we do field schools, and we do field school activities in each year. And in the final year, we do an overseas field school to Singapore. Part of this is in relationship to the unique history in terms of global trade and finance of Singapore, but it also is a key geopolitical spot, an interface, both historically and also to the present day. I mean, interesting here, if you had time, Changi Chapel is near Changi Airport in Singapore. It's where in 1944 the Allied prisoners of war built a Catholic chapel. In 1945, when Singapore was liberated, that chapel was packaged up and shipped back to Australia. Amazingly, that materiality and presence stayed in a box until 1988. And the RMC here in Duntroon renovated it, and it's now standing not so many kilometres, about a kilometre away from where we're here today, as a memorial to the 35,000 Allied prisoners of war. So a bit of history there that connects us to this place, to the field school, and to the present, to the past. On to maritime. Maritime, a new area of Bachelors of Science. It's a new major this coming up. Again, across the 2 schools. So you have engineering mechanics, mechanical aeronautic and naval architecture engineering, naval architecture practice, hydrostatics and stability, mechanics of solids, Australian waters and their dynamics, and we're leading in a bit more to oceanography here, ocean circulation and mixing, ocean waves and modelling. And that's why maritime and oceanography can't be paired as a double major or a major minor because of the overlap of courses. We'll come on to that. Mathematics, fundamentals, algebra, calculus, then data analysis, discrete mathematics, differential equations, mathematical modelling, waves and fluids. Every student here at UNSW Canberra, ADFA, does some maths. So every student goes through the science school at some point. Obviously, as you go through, that's mainly the basics. Fundamental data analysis is the main course. As you go through, you're applying it in relationship to engineering, and obviously clearly some physics there with waves and fluids. Oceanography, those topics that are in the maritime come up. Ocean waves and modelling, Australian waters and their dynamics, ocean circulation and mixing. The oceanography courses run in years 2 and 3. It's not in year 1. The year 1 is made up of the other science fundamentals. Physics, final discipline, I think. Atomic and nuclear physics, doing more in that space, in nuclear science. Meteorology, waves and electronic materials, astrophysics, electromagnetism, and quantum physics. Quantum physics is a cutting edge at the moment, a lot of tech at that space. Diving into the courses, again, I'm going to go through this quickly, but I'll give you an example, run through an example. I mean, what is the degree? The degree is 3 years. What do you need to do in that 3 years? You need to do 144 units of credit. Generally, per semester, you are doing 4 courses, so 24 units of credit. So over two semester years, that's 48 for a year, 3 years gets you up to 144. The double major minor component is 48 for the major, 36 for the minor. You can pick up the other 12 in different electives. In level 1, you need to be doing 24 units of credit. I'll show you how the other 24 gets made up in that first year. Years 2 and 3, you need to have at least 36 in the major in years 2 and 3, and at least 18 in years level 3. All students also, throughout their degree, take general education courses, as well as 1 or 2 prescribed electives. There's a little bit of choice, but obviously if they're prescribed, there isn't. But here's a bit of what that choice is. You can choose between Introduction to Strategic Studies or Strategic Management and Leadership. And then you can choose between Law, Force and Legitimacy or Introduction to Military Ethics. So these are outside of whatever degree you do, you can be doing them. Plus, you do Introduction to Cybersecurity, all students do this, and plus if you don't take Maths 1A, this is why every student here does Maths in some form, you will do Fundamental of Data Analysis in year 2. So let me unpack that. And this is a kind of suggested study load, if we run through that in particular, year by year kind of account. First year level 1, study load, as I've said, is 4 courses or 24 units of course per semester, so 48, and that's for full-time study. We recommend 3 or 4 science courses per semester, and you can take those from aviation, chemistry, computer science, geography, maritime physics, and mathematics. Plus at most 2 science, arts, business courses as electives, e.g. maybe you take a science elective, timetable permitting, from the other majors. And in particular, the new elective we have that doesn't sit in a major at the moment is nuclear science and applications. In year 2, the same deal, 4 courses, 24 units of credit per semester, leading to 48 in the whole year. But here we start to kind of look at the difference and how you can make this up. And this is assuming a major minor. So in science, in 1 semester, you would do 3 courses of science with 1 elective. That elective could be the general, that's 6, or it could be the free course elective, another 6. And then in the second semester, you would do 3 courses. So that kind of cadence of 3 quarters in your main topic, and then something else to keep your brain fresh as you go through the year. In year 3, 4 courses, again, the same thing, 24 units of credit per semester. Again, and then in science, in the science major, you'll have 3 courses, 8 units of credit. If you're doing the minor, you would then have that 1 course plus the choice of 2 upper level science electives with 18 units of credit, plus then you could have your 6 units of credit. So that is a space where you can start to kind of tailor make your degree a little bit. There's not huge amounts of choices, but there's a little bit of movement. I'll say one quick thing about the kind of perhaps constrained choice. It does mean that we can take you to a higher level. A lot of universities sometimes mix second years and third years. We do that a little bit, but that's because we're enabling students to catch up and we have to manage their program carefully. But in the norm, we don't, and that means that therefore, from second year to third year, we can take you to a higher level. Does that make sense? And I think that's an advantage. Not all universities do that. In terms of then how that might look in terms of units of credit and how it becomes, you total up the 48 if you just take the physics major column there on the left. 12 in the first year, 18 in the second and third year to equal 48. And then in the minor, you build it up to 36 because it's a major minor physics maths combination. You have those electives that pull in another 12. In the first year, you have that 24 that you do in the free electives, and then you have another 6 in the second year. In the second and third year, you have the general ones, plus you have the prescribed. And that all combines to make sense of, where you're majoring in any discipline is actually could be quite small component, so effectively 1 year. Again, remember with science so that you're feeding off some of the fundamentals from maths, even though you might be doing the major in physics. Obviously, if you're doing the double majors, that will come in a kind of tighter number, which I'll show you in a minute. Just to highlight, though, is that each major must contain 48 units of credit of courses and each minor 36. So there you can see that the physics adds up to 48, the maths minor adds up to 36. And then that leads to the minimum of units of credit to get a BSc in science in terms of the major minor. And again, each minor must contain 24 units of credit at the upper level with at least 6 at level 3. For an award of BSc, which is the point I've just made, there must be at least 96 units of credit of science courses. However, sometimes that might be higher. In this example, there might be as many as 126 units of credit of science courses. That will differ from different programs, university programs across Australia, about the level of actual content of science that you take. But 96 does give a strong integrity to the particular specialisation of degree that you do here. The kind of combination of double majors, and again, this is something you can chat to and ask students about their experiences of their major, minor or double major. These are the combinations that you can have. As you can see, everyone at some point will be doing maths to get a science degree. You then have the choices depending on the prerequisites and how the different degrees marry up. There is some timetabling issues with chemistry, physics having quite large lab classes, and that can constrain some of those double majors. But there's a lot of choice, there's a lot of courses there, each tick is a different combination, and you can make up quite a few, and those are the double majors, and it's a similar deal with the major minors. What I will talk about here, and it is something that we get questioned about, is the assumed knowledge in and around the science program. So maths is obviously fundamental, so almost all major minor combinations in the BSc at UNSW Canberra will include a mathematics 1A, 1B in the first year. They need to do that. For that, there's an assumed knowledge. Intermediate level senior mathematics is assumed knowledge for the BSc degree at UNSW Canberra. So therefore, we assume that students who arrive here have a strong background in algebra and calculus from their prior studies. Also then, students completing majors or minors in physics or oceanography, or majors in aviation should also have studied senior physics, and that's the kind of assumed knowledge. I mean, that said, we do a lot of work with students to help pick up their fundamentals and remind them of algebra and calculus in particular, where they might struggle. I mean, it's interesting, it is a language, and how that is taught is different from institution and countries to countries, and certainly in the past was different from state to state. I have to say Queensland has upped its game in a few years and changed that, but in the past they were a little bit behind. I can see some smiles from students who know about that. But what that means is that we can't assume that everyone has learnt the language the same way. So we do a lot of work with students to get their support up. I often get asked, should we do some bridging course? And of course, you're coming straight into to ADFA. We don't have that period, before you get here. And so we do encourage and do recommend some online bridging courses. There's no harm in doing that to get you up to speed. I think you'll find that an advantage if you struggle with maths coming here. But again, it's a good one to ask the students when we get to Q&A. Entry requirements. The 2026, an undergraduate entry requirement is indicative, it's not absolute, for Bachelor of Science at UNSW Canberra. The ATAR for basic requirements is 75. For the CDF requirement, it's 95. It is competitive to get in here, and students do arrive with higher than 75. What's also interesting, of course, is the recruitment to get in here is broader. It's a bit like some of the universities in the UK where you have interviews and there are other characteristics that are looked for. And I think that's fantastic. And the students that we do have here, you are fantastic. It is a privilege to teach you. The staff-student ratio does mean that you can get to engage with them, it's a very vibrant environment, not just for the kind of military side of things, but also for the academic side of things. You want good peers, you want to have ambition, and you want to lean on that. So what I'll do now is I'll invite the TOs up, Alston, Kate, Kane and Zoe, and I'll ask them to come forward just to introduce themselves to you, tell you your year, and also their major, minor, and then we'll open up to Q&A. So while they're doing that, think of any questions. I appreciate I've rushed through some things, but I just want to give you an overview. So.
Yes, good morning everyone. I'm Kane and I'm studying, of course, science with majors in physics and aviation, and I'm in my second year.
Hi, I'm Zoe. I'm doing a double major in aviation and geography, and I'm in second year as well.
Good morning, my name's Kate. I'm a third year student studying chemistry and maths, and my role is an aviation warfare officer.
Morning everyone, my name's Alston. So I'm a third year, I'm doing maths and aviation and I'm a pilot in the Navy.
Great. So over to you for questions. There's a question at the back.
What was the CDF in regards to the ATAR?
Okay, so for those online and in the other room, the question is, what was the CDF? The CDF is a Chief Defence Force specialised cohort when they do more study throughout the 3 years. So it's kind of aiming a little bit higher towards a more honours kind of degree. They don't get an honours, but it's that kind of idea. So it's just kind of enhanced education over the 3 years. Yeah. Any questions? Yep.
Sheer knowledge of maths and physics. That's a prerequisite. General maths in last year of school enough, or would be required to have an advanced maths subject?
We would rather, it's assumed knowledge for an advanced maths subject, depending on the degree. So if it was for maths, we would assume and want that. So it's a senior mathematics, yeah.
With regards to the CDF, I understand that it's by invitation. What's the criteria to obtain an invitation?
First of all, I think it's the level of performance from the student in relationship to how they're tracking for their ATAR. And then that's a question for defence recruitment, not for UNSW. Oh, yeah, perfect, great.
Yes, so even though it's a 95 ATAR requirement, it isn't actually offered until the start of the second semester in first year. So you'll receive an email if you received a weighted average mark for your first semester over 85. So I haven't really known anyone to actually look into the 95 ATAR. They just look at your WAM in the first semester and then base it off that. So yes, if you get a 95 ATAR, that might be indicative of you then getting an 85 WAM, but it is entirely possible for you to work hard in your first semester and receive a WAM of above 85 and be offered that course. So, nice.
Yeah, question there.
Just a couple of questions around more about more general questions, but when do you have to decide what type of degree you need to do? And similar for science, is there a view of which major and minor you should choose, or is that also a recommended, because you get sort of advised as what you should be doing based on your future career, based on your future career choice?
I'll start the answer because there'll be two sides of this story, I think. One, we want you to be doing the topics that you want to be doing. And my understanding mostly with, defence workforce down the line, they're not looking for absolutely generalist, but they will assign students later on. They'll have some jobs in mind, but, those things can be trained up separately. So I wouldn't be looking for a particular end game role, but I would certainly start from an academic point of view with what you're passionate about, and based on how you can manage some of those, whether the level of maths, for example. We can pick students up, but I think it's go with what your strengths are, with what your passions are. We do try and be flexible. I don't know whether any students here have changed their combinations when you came in.
Not originally for my intent, but I'd say that you can keep it quite open at the start, especially in your first year with the amount of electives you can pick. It's general that you can do, for example, myself, I did maths, chemistry and physics in my first year. So when I went to choose my majors, I did have the option to pick a combination of those three. I ended up going with my original, which was chemistry and maths, but you can keep it quite open at the start and find where your passion is and just do what you're interested in. Yes, you think, I might be going into a pilot role, therefore I want to study aviation. You're going to be studying aviation once you leave here, going into your job. So if you have passion in chemistry or physics or something, go and do that, because this is your time to study what you're really, really interested in, and ADF will give you your job training when you need it after here. So really focus on what you're interested in, and if that's not necessarily 100% related to your job, especially doing a science degree, then do that, because the engineers have to do engineering because they're going into an engineering role. So this is your chance to go and do what you're interested in. Yeah.
Yep, question there.
Just on that, how much has aviation assisted with your pilot course and training?
So the question is, how has your aviation assisted with your pilot course and training?
Yeah, so going off of what Kate had said, it's really good to have your interests. For me personally, with aviation, it was a pretty no-brainer. I was good at maths in high school, and I was good at aviation because of what I wanted to do. As far as direct correlation to your job, the ADF trains you completely for what they need. There's definitely some benefits in knowing the backgrounds of things like, Sir spoke about air traffic management. That's not really something as a pilot I'd touch on, but it's good to know from the background of what their job does. As far as prerequisite sort of thing to aviation, it's not that mandated, I guess. Like, you can do without it, because again, ultimately, once we graduate this place, we all get trained for our jobs anyway, as to what the ADF requires.
Question at the front.
Of the number of students who have completed their education at ADFA, how many usually have completed majors or minors that are science related?
So the question is about how many students that go through ADFA have completed their major minor in science with a Bachelor of Science. It's around about 70 out of about 350, I think we're going up to. I mean, it will go up a little bit. It's not as many as you might think. Yeah. Any other questions? The question there, yeah. Oh, sorry, yeah, perfect, yeah. So I'll go there first and then to you. Sorry. So the chap in the pink shirt. Sorry, there's any... So the question is, are there any research opportunities at the Bachelor of Science? Yes, there is. We do offer in the third year research projects. And so even the Singapore Field School, we're kind of that course is around training the students in certain philosophies, methodologies. We kind of guide them in certain study areas in Singapore, but then they are actually devising their own research project around that. It's the same with oceanography and physics. And again, there's often components, particularly around some of the lab-based late parts in the third year, and also then in any field school activity in geography. You can always chat to, academics. A lot of academics will actually, especially in the labs, will generally at different times show you some of the experiments they do. They may not have done it yet, yeah. And actually the new aviation lab with he's very excited about that. I don't know, have you seen it yet?
Not yet.
No.
We're hoping to get in there soon.
Yeah, I'm trying to get it done. But it's very good. Microsoft Simulator, here I come.
So for the vocation of the pilot, is there any preference to do the BTEC, aeronautical engineering versus aviation? And my second question will be, are there any practical aspects of flying with aviation course?
So this is a question for aviation. The first question was about whether a preference for BTEC or Bachelor of Science for aviation pilot. And the second question has escaped me. Sorry, what was it? Yeah. And are there any practical flying hours for aviation? Hand it over.
Yes, I'll answer the second question first. There is no practical flying in the university component. If you are going on to do pilot training, you will do all of your flying through Defence in the pilot training system. No actual physical flying is done with UNSW. And the first question, forgive me, sorry, would you just...
BTEC or BSc.
Oh, BTEC or BSci. There is no particular preference to doing one or the other. I should make it clear that none of us have done our pilot training yet. That's all done after ADFA. But very much do what you are interested in. Don't be thinking, I need to pick a degree that prepares me best for pilot training. We have so many pilots and AVWOs go through who are doing business and arts and computer science. This is your chance to be broad before Defence focuses your training.
Just adding on to that, when I came in as a BTEC student, and after a week I just decided that wasn't for me. And it only took the military about a week to approve to change to science as well, so they don't really mind too much.
Right, thank you. Any questions? A question on stairs, yeah.
So can you get a job in the Air Force before you finish your degree?
So the question is, can you get a job in the Air Force before you finish the degree?
Yeah, so when you sign on, we're actually already technically serving military members. So, and then after you got given your job that you apply for, then you can kind of think about what degree you want to do. And they kind of tell you what degrees you should do based on your job. And then once you graduate, then you just go straight off into the military.
I'll just add broadly, since we don't have any Army represented here, so Navy and Air Force both know their job role before they come to ADFA. So Navy will do their officer training before coming to ADFA, knowing their job role. Air Force will come straight to ADFA knowing their job role, whereas Army come in as general service officers. Some come as engineers. But then more specifically, engineers will do an engineering degree, whereas most other roles you can pick whatever you want. Yeah.
Question right at the back.
Can science students extend their education to an honours year?
They're asking, can science students extend their education to an honours year here? They can. It will have to be, it's dependent on the force that you're in and their requirements year by year. But I've certainly had honours students. I know of, we have a couple in geography quite often and chemistry. And so, yes, the answer is yes, but it's not, it's dependent on where you're being put and what discipline you're in. And that can change from year to year. Is that fair? Yes. A question here.
The balance between the academic side and then the defence corps side.
Yep.
As you go through,
Yep.
does it vary or is it pretty constant?
Yeah, so it's a great question about whether or not, can we talk a little bit about the balance between the defence and the academic side? I'll hand it over to them and I'll counter any deviance from the...
Yes, I would say it is weighted towards the academics more so. But so when you arrive here in your first year, your first 4 weeks is pure military initial training. And then once you're out of initial training, the calendar is between 7 a.m. till 10 a.m. is pure military training, and then from 10 a.m. through to some classes run until 6 p.m. is your academics. Time after that is usually your own or time devoted to your clubs and your vacations. So that's the general split of military to academics. In addition to that, we have a few field exercises. There's usually one field exercise per year as you go through here. And also for all services actually, in the academic breaks, there will be single service training blocks, more so for the Army and also the Air Force, whereas Navy, we do have some, but they vary very much per your primary qualification that you'll be going into afterwards, as we already do our Naval Officer course before we join ADFA.
Is that pretty constant from years 1, 2 and 3, what you described today?
The activities, yes, that is consistent between years 1, 2 and 3. Perhaps one of the year 3s would like to add on to that.
I'd say they have brought in new programs recently this year to increase the military training to prepare us more for the future, including more SSTs. But yeah, the amount of SSTs per service per year group does change. So you can't predict when they will be. The Army more so can, but the other services can't always guarantee their leave period because they may bring in impromptu extra training. So it's not always guaranteed, as with anything with the military, but on the most part, you can guarantee at least some leave throughout the year, and then a combination of military and academics, yeah.
Yeah, so single service training, SSTs. I think the balance is really interesting, and it does change from commandant to commandant, and that can be a 2-year cycle. And that's good. I think that's healthy because, again, you get these different ethos that get inculcated again into people. I mean, as you get older, when you get into your 40s, getting into the habit and being accountable for going to the gym helps you a lot. So I'm quite envious, actually, of what's being put in at the moment. And I think, that environment is a really healthy one, and it's not just physical training, but it's also, around the kind of skills you do study in terms of, debating and the kind of many, what do you call them? Golf teams, drama teams, music, all these things are encouraged, so I think it's a great breadth to the kind of time that they have here. Question in the middle.
Is the payback period per se, like how long you have to stay in the services for, does that vary by your degree or your service area, like Navy, Army, Air Force, etc.?
Yep. So what you're talking to is the return of service timings. So that depends on your job role and your training. As far as the degree, correct me if I'm wrong, but it's always just the length of your degree. So for example, the science degree is 3 years. If I were a direct entry Navy pilot, my return of service would be 11 and a half years. If I didn't go to ADFA, it would just be that. Since I've gone to ADFA, you add the 3 years on, so it becomes 14 and a half years. And that's all in your COS that you get when you get your letter of offer. For engineers, if anyone was interested in that, I think that changes as well. It might add another year on. You'd have to talk to an engineer about that, but I'm pretty sure it adds another year on. Unless, yeah.
There is also a grace period at ADFA too, which is 2 years. So you have up until the end of second year to discharge if you don't like it. In the Air Force as a pilot candidate, our return of service is 9 years, but it doesn't start till after our pilot training. So.
I guess referred to COS earlier. COS is your conditions of service that you receive upon enlistment. But for specific information for a particular degree and a particular job role, I'd defer that to the DFR stall over at the Adams Auditorium. They'll be very helpful.
Any more questions? I mean, if not, we want to be moving out of here to free up the room for the next tour. But equally, given that we've got a quarter of an hour, it's a good opportunity perhaps if you wanted to chat to the TOs, just to come down and ask them quickly, mindful of perhaps continuing those conversations up the stairs. And thanks to all those that are attending this online and in the spill-out room.